Okay, here we go. Let's look at number one. To do this, everybody knows that the fraction line means division, right? So you can read this as the square root of 15 divided by 4 square root of 12. But to do division with radicals, we don't actually divide. We do something that's called rationalizing the denominator. Ever heard of that? It's called rationalization, rationalizing. In other words, we're making an irrational number a rational number. It would take me about 5 minutes to explain that, so I'm not going to. Here's how you do it. And when you get to pre-cal trig, if you're going to take anything in trigonometry, you got to know how to rationalize, right? All right. We want to get rid of the square root symbol in the denominator. Now, how many of you remember? Some of you aren't listening. I've already lost you. Learning is listening. Learn how to listen. How many remember that when we have a situation like this, you've had a couple of problems yesterday like this, what happens? But you get the square root of 25, which is, okay, let's see if we can see a pattern here. What happens every time? It's just the number, isn't it? Right? So please make that deduction. Please notice that. To get rid of a square root, you multiply by the same square root. You follow me? So if I want to get rid of the square root around the square root of 12, what am I going to multiply the bottom by? No, not 12. Square root of 12. Didn't I have multiplied the square root times the same square root here? This equals 3. This equals 5. This equals 7. This equals 11. So multiplying by the square root gets rid of the square root. It's the same. Push the button there. Get the paper over there on the table. Okay. Oh, that was for you. Huh? All right, so here's what we're going to do. To divide radicals, we actually rationalize them by multiplying by the square root of the denominator. So we can get rid of that. But you know what I'm getting ready to say? Do you know what I'm getting ready to say? Thank you, Joseph. Somebody's thinking. Whatever you do to the bottom of a fraction, because we can't change the value of the problem, we're actually multiplying by what here? Isn't the same thing, something over itself equal 1? So therefore, if I'm multiplying by 1, I'm not changing the problem, but I'm changing its form. I'm getting rid of the fraction or the square root in the denominator. Now you know what to do at the top, don't you? Inside, both of them are inside, so take 15 times 12. Go ahead and multiply that. 150 plus 30 is 180, isn't it? How many got 180? Okay. Now watch you do the bottom very carefully. Let's see if you know what it is. You shouldn't have to use your calculator. What did I just teach you over here? Thank you. 48. You don't need a calculator to do that, do you? What's the square root of 12 times the square root of 12? 12 times 4. 48. Now, we would be finished, except now you can simplify the square root on top. You already know how to do that. Does anybody remember what it was from yesterday? Didn't we have a square root of 180 yesterday? No, I mean, what was the answer, though? You're right. 6 square root of 5, wasn't it? How many remember that? Yeah. Because actually 180 is the same as this. Doesn't 36 have a perfect square root? So now we have 6 square root of 5 over 48. Are we done? No? You have to think inside, outside. Aren't the numbers outside, can't they be simplified? Won't 6 go into itself once? And how many times does it go into 48? Now we are done. Having fun yet? This is a blast. You just don't know how to have fun with math. All right. Let's review a little bit. First step is you multiply by the square root in the denominator, don't you? Top and bottom. The next step is simplify. Simplify the square root and simplify numbers outside, then you'll be done. See if you can do number 2. Oh, you already got it. Yeah. You're always working ahead. See if you can do number 2. This one's a little easier. Let's see if you started right. What did you multiply top and bottom by? Square root of 3. Then what did you do? What does the top one simplify? 3 square root of 2. How many got that? Excellent. Now I'm going to show you another method that's even quicker, but I wanted you to understand how to rationalize. Because you can't do what I'm getting ready to do every time. This won't work all the time. But there's a rule with radicals. The square root of a over b is the same as the square root of a over the square root of b. In other words, taking the square root of a fraction is the same as taking the square root of the top and then the square root of the bottom. Or you can go in reverse. If I have this, I can write it like this. So what if I took this and wrote it as the square root of 6 over 3? Oh my goodness. What's 6 divided by 3? And I'm done. Got the same thing I got here, don't I? How many saw what I just did there? Now you can only do that because both of these have a square root on them. That's why I can put this and write it like this. The square root of them individually is the same as the square root of the whole fraction. Then if the fraction simplifies, doesn't that make it a little easier? Now this is going to be up to you. The first method works every time. The second method only works some of the time, and you got to know when to use it. Look at number 3. By the way, give yourself 2 bonus points if you got that right. Now see in number 3, oh, that's easy. We don't need to rationalize that one. First of all, look at the square root of 5 and square root of 4. Would it do any good to put them under the same square root? Would they be able to be simplified? 5 over 4 wouldn't reduce, would it? So that's when it's not, you don't do that. But you do know the square root of 4, though, don't you? So write the answer for a bonus point. Write the final answer for a bonus point. What's the answer? Yep. How many had the square root of 5 over 8? Okay, give yourself a bonus point. What's the square root of 4? 2. 2 times 4 is 8, isn't it? And there's really nothing else you can do to that. Remember, our goal is to not have any square roots in the denominator. Yes. If you multiplied top and bottom by square root of 4, you'd get the same thing after you simplified it. That's not right, though. It's got to be square root of 5 over 8. All right, we're done with those. Now, this is totally different because now we have a binomial on the bottom here. I think you'll be okay on the first ones that we did. I'm going to rewrite this out here where I have a little more room. Now, the negative doesn't affect your answer. It just stays out front right now. No, actually, let's do this. What did I always teach you to do when we were doing, do you remember the fractions we did when we did the, yeah. Or I also told you this. When you have a negative on a fraction, where else can that go? It can go on the bottom or the top, but there's only one negative. There's not two. You don't make them both negative. There's only one negative. So I really could do this, which is a good thing to do, like we did with minus and plus and negative. Just move the negative to the top. Smart thing to do every time. Now, this is the one you're going to have to pay attention to. It's different. I'm going to write it over here. We've got negative 4 over 3 square root of 5 minus 4 square root of 3. Well, new word. And this is not like in English or Latin or foreign languages where you do the conjugation. It's called the conjugate. And a conjugate is not the opposite. The conjugate just changes the sign in the middle. So anytime we have a binomial on the bottom, to divide, you multiply by the binomial's conjugate. And this is what it looks like. You just change the sign in the middle. Write this down. Now, do you see under the denominator of what we were given to begin with, the only thing I changed was this, right? You see that? These are conjugates of each other. They're called conjugates in math terms. And they actually come from this. Anybody remember this that I used to have on the board? Do you know what that equals? Difference of 2 squares. Joseph, you are good today. Very good. Remember that? That's how you factor the difference of 2 squares. Well, didn't tell you that these were called conjugates then, but that's where the conjugates come from. Because what do you end up doing when you have conjugates? You just a squared minus b squared. Same thing, isn't it? So, you got to put binomials around this. And you're going to have to distribute on the top. Distribute on the top. Go ahead. To divide when you have a binomial in the denominator of this type, You multiply by the conjugate of the denominator, top and bottom. Well, this is just distributive property. So don't we have negative 12 square root of 5 minus 16 square root of 3. Right? Remember, inside, outside multiplication. 4 is on the outside, so it can only be multiplied times the outside. Does that make sense? Okay. Yeah, because we're doing some similar stuff that we did before. We're still doing it. Now on the bottom, I want you to FOIL that for me. Distribute it. That was on the last assignment. Go ahead and do that. I want to see what you get. I think I've changed my mind about your quiz tomorrow. We're going to make your quiz Friday. Since this stuff's a little bit harder, I want you to really to have time to get this. So, how many problems did I give you on the other side? 20? Okay. I'm going to give you time to work on this in class tomorrow so you can ask questions. We're probably going to get done here in enough time maybe to have 10 minutes left, but because we still got to do some at the bottom down here. All right, let's see what we get here. First we take 3 square root of 5 times 3 square root of 5. That should be 45. Anybody get a 45 there? Can anybody tell me, explain how I did that quickly? Which is 5 by 9. All right, look at this. Then you all can do this. You're not used to using your brains. You're used to using your calculators. Remember, inside, outside. What's 3 times 3? 9. Square root of 5 times square root of 5 is 5. Remember, we learned that earlier, that the same root times itself, just that number. And what's 9 times 5? 45. All right, let's do the next one. Now this one isn't going to be as easy, not going to simplify as much. 3 square root of 5 times 4 square root of 3 is 12 square root of 15. Is that right? Then what do we get when we do this one? Yep, they're going to cancel, aren't they? Now, can't you do the last one like I did the first one in my head? If you take 4 square root of 3 times 4 square root of 3, that's 16 times 3, which is 48, isn't it? Minus. So it looks like your answer should be negative 3. Did anybody get there before me? Excellent. Give yourself 2 bonus points. But that was to find the denominator. Now, you can't simplify that unless the 3 on the bottom goes into both of the outside numbers. 3 doesn't go into 16, does it? Now, you could do the negative. The negative could be moved up and change everything to positive. I don't know if you'd understand that. But this answer probably would be written in the book as 12 square root of 5 plus 16 square root of 3 over 3. Because I can take this, isn't a negative over a negative positive? And a negative over a negative positive? You don't have to do that if you don't understand it. I'll take this. But all 3 of the negatives cancel. They make a positive. Now, what I want you to see, though, do you notice how these canceled and all you had was 45 minus 48? What did I say happens with this? When you multiply by the conjugate, isn't it just a squared minus b squared? Well, if you took this squared, you get that. Isn't taking it times itself squaring it? And if you take this squared, you get that. Isn't that what we did? Took it times itself. So isn't this a squared minus b squared? Just like that. See, I don't have to go through that whole FOILing process. When I notice I've got some conjugates, I just take a squared minus b squared. And I'd get -3. I could do that in my head real quick. Now what's your question?
How do you get the
-4 times 3. All right, I want you to try one on your own. Do number 5. Try number 5. This one's a little easier. Doesn't have as many square roots. I'm sorry? You can't wait? Huh? Okay. Did everybody use that as your conjugate? You don't change the -3. The only thing that changes for conjugates is the middle sign, one in the middle. And if you understood what I taught you about the a squared minus b squared, you can do that on the bottom pretty quick. It'd just be -3 squared minus the square root of 3 squared. Because we know the middle two are going to cancel. Now if you don't understand that, you can always FOIL or distribute. You can still do that and get the same answer. All right, what do we get on top? Distribute, and you'll get -15 plus 5 square root of 3. What do we get on the bottom? Somebody said it. Was that you, Nicole? Now, how many got 6 on the bottom? Oh, so we got some problems here. Did you distribute, or did you try my a squared minus b squared? Distribute. Well, let's FOIL it if you're not sure. What is -3 times -3? +9. What is -3 times square root of 3? -3 square root of 3, isn't it? What's a negative times a negative here? +3 square root of 3. Remember, this should always happen. They're gone. But what's a square? First of all, what's a square root times itself equal? The same number. But don't we have a negative times a positive, which makes it? I think 9 minus 3 equals 6, doesn't it? How many got that 6 again? Give yourself 2 bonus points. Now, the next thing you check, this could be our final answer, right here. The next thing you check, can I simplify? And the only way you can simplify is if the square root can be simplified, which it can't. Or is there a number that can go into all three? No. Almost. 3 will go into these two, but 3 won't go into 5, will it? So this is your final answer. Okay, did anybody get that total answer correct? Excellent. Give yourself 3 total bonus points. 2 for the 6, 3, 1 more if you got that top. All right, now we got to do some like at the bottom. Number 6. No, we already did one like this. Number 7. We still do the same thing, except this time on the top we've got another binomial, don't we? So you're going to have to distribute on top and bottom, which you already know how to do because we did that yesterday. But what do I multiply both top and bottom by here? 5 minus square root of 2, right? Since this is 5 plus square root of 2, we have to multiply by its conjugate on top and bottom. So that means I've got to distribute top and bottom. Go ahead and do that. You should know how to do that. Now you may have a lot to write on the top. In fact, I think you end up with 4 terms up there because you can't combine them all because they're not like radicals. Mariah, what'd you get on the bottom? Very good. How many got 23 on the bottom? Yes, that's right. Now I'm going to do this. This is what I do in my head. Because remember, if you have conjugates, you can do a squared minus b squared. This is your a, this is your b. 5 squared is 25. Square root of 2 squared is 2. 25 minus 2 is 23. Isn't squaring a square root just get rid of the square root? Same as taking it times itself, which gets rid of the square root. Now, if you can't do this consistently, then you'd have to distribute, and you know the 2 middle terms are going to cancel. All right, what do we get on top? 15 when we do 3 times 5 minus 3 square root of 2, right? Then what? Plus 20 square root of 5. Because we have this times this, right? Minus 4 square root of 10. Correct. Now you'll notice I don't have any numbers to combine with the 15. None of the roots are alike, are they? So we can't combine any of them. This is your answer. Unless this number would go, we'd find something going into all these numbers but on the outside, and that won't work either. So that's your final answer. Now I need you to try one on your own. Do number 8. By the way, give yourself 2 bonus points if you got this done and correct. This will be our last problem. How many already got an answer? Excuse me. What did we get on the bottom? -1? You forgot to square that. What's 2 squared? Square root of 5 squared. 4 minus 5. I think did you take 2 minus 5? Yeah. See, this doesn't have a square root symbol around it, so you have to square it. Does that make sense? All right. Now, if you FOILed this, you're going to get 4 when you do this, minus 2 square root of 5 when you do this, plus 2 square root of 5 when you do that, minus 5. These cancel, and you end up with 4 minus 5, which is -1. All right, on the top, what do we have? We have 8 minus 4 square root of 5 minus 10 square root of 2. Oh, this will be a plus what? Yep. Now, this is an answer I wouldn't leave like this. What does dividing by a negative do to everything? Well, no, it doesn't make it positive necessarily. Changes everything to its opposite. So I expect you to do that on this type of problem. So your final answer that they would have in the book would be -8 plus 4 square root of 5 plus 10 square root of 2 minus 5 square root of 10. That would be your answer. Who said cha-ching? All right. You must be feeling better. Give yourself 2 for that if you finished it, got it right. Tomorrow I'm giving you the whole period to work on this assignment. You can start on it. I hope you kept your notes so you'll know how to do the first set of problems that we did, because a lot of times by the time we get done you forget what we did on the first part. You can start, but tomorrow I'll give you the whole period to work on this. Yeah, hold on a second here.